Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 26 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a table showing the value of dollars of a motorcycle at the end of X years, and we do know that it is an exponential function. Okay, so what do we know about exponential functions? Well, our standard form here is going to be y equals a times b to the x power. Each of these terms means something here. So a can mean, if we're dealing with investment and compound interest, it can mean our principal. It could also just simply mean our starting amount or initial amount. If we're dealing with population growth or bacteria, there's always, it started like this, then it got bigger, got smaller. Or if we are dealing with graphs and tables, we can view it as our y-intercept. Y-intercept, remember, is when you're graphing and the graph crosses the y-axis at x equals 0. Well, look what happens up here if we make x equals 0. I'm just going to replace that x with a 0. Well, it's a times b to the 0 power. Anything times anything to the 0 power is just 1, so it's just a. So when x equals 0, y equals a. So that's good to know, because take a look right here. We have our y-intercept. We have x equals 0, and then so we know that that a is going to be that 9,000. All right, so what is b going to be? B is your rate, and it's going to be a growth rate. If it is greater than 1, it is going to be a decay rate if it is less than 1. Now, we don't know what the rate is yet, but we can make an inference in just a second, and then your x is going to be your steps. And a lot of times it's going to be time oriented, like every year, every month, every week, every day. In this case, it's the number of years, so we'll say it's our years in this problem. Now, going back to our b, we can make an inference about our rate, because look what happens as the years progress. 0 to 1, 1 to 2, 2 to 3. Look what happens to the value. It goes down each time. So we can say it is going to be a decay rate. So this is what I'm looking at right now. I'm looking at my principal, my starting amount, when x equals 0, then y equals a. So in this case, y is going to be our v of x. So then that means a equals 9,000. Okay? Which means we're going to get rid of h and j as possible answers. We did say that this is a decay rate, which means it's this b term has got to be less than 1. Well, take a look. I've only got two options. G is looking pretty good, because that f would be a growth rate. It's greater than 1. Now, how can we know for sure? Well, there's a few different ways we can do that. Since each of these have a step of 1, what we could do is we could take each of these v of x values, so 65, 61, and then divide it by the previous one, 7290. And this works because we have a step of 1. We can take your 7290, we can divide it by 8100, or you can take your 8100, you could divide it by 9,000. Either way, you are going to get 0.9, exactly what we thought. So our b is going to be 0.9. Another way to do that would be to write your, let's say, 8100 equals, and then your a is 9,000 times b to the 1 right here. You just take your v of x and then your x, and you just plug them in here. Either way, our answer is G.